If Earth were observed not from space, but through the lens of ambition, some regions would stand out like signatures carved into the planet itself. Rivers would bend on command, mountains would be pierced, not avoided. Oceans would be crossed as if they were roads. Energy would travel thousands of kilometers without pause, and steel would hang between sky and stone, defying gravity itself. These are not natural formations. They are the result of human will pushed to its absolute limit. Today, we take you inside China's 10 greatest megaprojects, from bridges suspended above the deepest canyons on Earth to airports the size of cities, canals that redraw maps, railways driven through the roof of the world, and machines powerful enough to listen to the universe itself. This is not just construction, this is engineering on a planetary scale. Let's begin. Beijing Daxing International Airport. If an airport reflects a nation's ability to move people at scale, then Beijing Daxing International Airport was built as a blueprint for the future of global aviation. Situated in southern Beijing, the airport covers more than 1.4 million square meters. From above, its terminal spreads outward like a golden starfish, forming one of the largest single-terminal airport buildings on the planet. But size alone isn't what defines Daxing. What sets it apart is efficiency. An entire mega hub operating seamlessly under one roof. The mission behind its construction was clear: relieve the growing congestion at Beijing Capital Airport and establish a new international gateway capable of serving the next generation of air travel. To make that possible, designers focused on a single guiding principle: shorten the distance between people and planes. No matter where a passenger checks in, the walk to the farthest boarding gate takes about 8 minutes. For an airport designed to handle over 100 million passengers annually, this level of efficiency borders on the impossible. Construction began in 2014, and the airport officially entered service in 2019 with a total investment exceeding 80 billion yuan. Completing a world-class superhub of this scale in just 5 years is almost unprecedented in modern aviation history. Daxing is also among the first airports in the world to fully integrate smart airport systems from the ground up. Self-service baggage drop, paperless boarding, AI-driven traffic coordination, and automated luggage sorting. None of this technology is meant to impress on display. Its purpose is simple: to make passengers forget just how enormous the airport truly is. Since opening, Daxing has reshaped Beijing's aviation structure and elevated northern China into a new tier of global air connectivity.
Huajiang Grand Canyon Bridge. This is a project that transforms the word impossible into measurable reality. With a total length of 2,890 meters, a main span of 1,420 meters, and a bridge deck hanging 625 meters above the canyon floor, it stands as the tallest highway bridge on Earth. The bridge slices cleanly across the vast Huajiang Grand Canyon in southwest Guizhou, China, a landscape so deep and steep it was once considered an unbreakable barrier. Before the bridge existed, vehicles were forced to crawl along winding mountain roads, turning a single crossing into a journey of several hours. Today, that same passage takes just 2 minutes. The greatest challenge was the terrain itself. There were no stable platforms on either side of the canyon, and placing any support at the bottom was completely impossible. Every conventional construction method failed. So, engineers took the only option left. They moved the construction site into the sky. Thousands of tons of steel girders were pulled across the canyon using massive traction systems, then assembled more than 600 meters above ground, with alignment errors controlled down to the millimeter. This extreme aerial construction method is used only when the terrain leaves no alternative. Construction began in January 2022, and the bridge officially opened to traffic in September 2025, a build time of less than 4 years with a total investment of 2.2 billion yuan. In the history of global bridge engineering, it is extraordinarily rare to see such scale and speed achieved together. And this bridge is more than a transportation link. It has been designed as a bridge tourism complex, featuring viewing platforms, glass walkways, extreme sports zones, and a dramatic canyon lighting system, positioning it as a future icon of mountain tourism. Yangshan Deepwater Port. On the global map of seaports, Yangshan Deepwater Port didn't follow the usual rules. While most nations dig their harbors deeper, China made a far bolder decision. It moved the port into the open sea and built it there. Shanghai has long been one of the busiest cargo hubs on Earth. The mouth of the Yangtze River is shallow, and as container ships grew larger, docking became increasingly difficult. In the age of ultra-large container vessels, any port without deep water access, no matter how busy, is destined to fall behind. China's answer wasn't to reshape the riverbed, it was to rethink the geography. Off the coast, in the Zhoushan archipelago, the natural water depth meets the draft requirements of the world's largest ships. Engineers reclaimed land between islands, built massive terminals, and installed an entirely new cargo collection and distribution system, creating a deep-sea port from nothing. To connect this offshore giant with the mainland, China constructed the 32.5-kilometer Donghai Bridge, a vital sea-crossing corridor that carries equipment, workers, and cargo flows day and night. With it, Yangshan became fully integrated into Shanghai's port system as a single operational entity. Construction of Phase 1 began in 2002, and the port entered service in 2005. Since then, Yangshan has expanded continuously, evolving into today's multi-phase superport. Phase 4 stands out in particular, one of the largest fully automated container terminals in the world. Rail-mounted gantry cranes, unmanned AGV vehicles, and intelligent sorting systems operate around the clock, handling global trade with extraordinary precision and speed. So why invest tens of billions of yuan to build a port in the middle of the sea? Because it removes a strategic bottleneck. With deep water access, Shanghai is no longer limited by geography. Larger ships, faster turnaround times, and more reliable global routes have allowed Shanghai Port to maintain the world's #1 cargo throughput year after year. Pinglu Canal. The Pinglu Canal marks a historic milestone. It is the first large-scale artificial waterway built in China since the founding of the modern nation. Stretching 135 kilometers, the project carries an estimated investment of 72.7 billion yuan, with construction costs averaging nearly 500 million yuan per kilometer. The scale of excavation is staggering. Engineers estimate that the volume of earth and rock removed could fill three Gorges reservoirs. This is landscape-level engineering. The canal begins in Hangzhou, Nanning, and ends in Lingshan, Qinzhou, forming a direct waterway to the Beibu Gulf. Once completed, it will support 5,000-ton class vessels, finally solving Guangxi's long-standing paradox. With the Pinglu Canal, ships will no longer need to detour through outdated inland waterways. The journey will be shortened by 560 kilometers, saving an estimated 5.2 billion yuan in transportation costs every year. But the canal's influence extends far beyond Guangxi. As a core project of the new Western Land Sea Corridor, Pinglu will dramatically improve logistics efficiency, expand bulk cargo transport capacity, and give Western China faster, more direct access to global maritime trade routes. Construction officially began in August 2022, with completion scheduled for 2026. For Guangxi and for China's western regions, this is more than a canal. It is a strategic artery capable of reshaping regional trade patterns and allowing bulk goods from the southwest to flow straight into international shipping lanes.
West-East electricity transmission. China's energy map has always carried a built-in contradiction. Power is generated in the west, demand lives in the east. Western China holds some of the world's richest energy resources, vast wind corridors, expansive solar fields, and massive hydropower basins. Meanwhile, the East concentrates China's largest cities, industrial centers, and electricity-hungry economies. Without a way to move clean energy across the country, this advantage would remain locked in place. That is why the West-East Electricity Transmission Project was born. At its core lies one breakthrough technology: ultra-high voltage transmission. With conventional power lines, electricity losses rise sharply once distances exceed 1,000 kilometers. The farther the power travels, the more energy disappears along the way. UHV changes the rules by boosting voltage into the million-volt range, allowing electricity to travel thousands of kilometers with far lower losses and far greater stability.
In simple terms, UHV turns continental-scale power delivery into a daily operation. Today, multiple UHV corridors stretch across China, carrying wind power from Xinjiang, solar energy from Qinghai, and hydropower from Sichuan and Yunnan to the nation's major consumption centers. The project began in the early 2000s. After more than a decade of construction, China has built the largest UHV transmission network on Earth. Each corridor represents an investment of tens of billions of yuan, crossing plateaus, deserts, mountain ranges, and thousands of kilometers of sparsely populated terrain. But the true impact of west-east electricity transmission goes far beyond long-distance power lines. It has restructured China's national energy system, allowing renewable power to scale, reducing dependence on coal-heavy regional grids, and turning geography from a limitation into a strategic advantage. South-North Water Diversion Project. The South-North Water Diversion Project is a vast hydraulic re-engineering effort that reshapes how water moves across China. Spanning thousands of kilometers, it redirects water from the water-rich south across mountains and plains into the arid cities of the north. It is not just a canal system, but a project that alters geographic limits, and it stands as the largest inter-basin water transfer scheme ever built. The system is designed around three major routes: the eastern, the middle, and the western lines. The backbone of the project is the middle route, which carries water from the Danjikou Reservoir to Beijing and Tianjin. Stretching over 1,400 kilometers, this gravity-fed corridor begins in Hubei, flows through Henan and Hebei, and delivers water directly to the heart of the North China Plain. The eastern route follows the historic Beijing-Hangzhou Grand Canal. Using a network of powerful pumping stations, it lifts Yangtze River water northward to support cities, industries, and agriculture in Jiangsu, Shandong, and surrounding regions. The western route, still under long-term planning and feasibility studies, is intended to one day divert water from the upper Yangtze into the Yellow River system, further strengthening northern China's water security. Since construction began in 2002, the South-North Water Diversion Project has supplied reliable water to hundreds of millions of people. Its purpose is clear: to release northern China from dependence on limited rainfall and fragile groundwater, and to provide a long-term foundation for urban growth, agricultural irrigation, and ecological recovery.